leadership begins with curiosity, courage, and a commitment to make a difference. It's about seeing what's possible and empowering those around you to make it real. Ayanna Howard has dedicated her career to advancing innovation, mentoring the next generation of engineers, and shaping education to meet the challenges of tomorrow. She is a pioneering robotics expert whose work has taken her from advancing autonomous systems at NASA's Jet Propulsion Laboratory to leading breakthroughs in human-robot interaction. Today, as Dean of Engineering at The Ohio State University, she continues to champion innovation, broaden opportunity, and shape the future of engineering education. Through her leadership, she demonstrates how an entrepreneurial mindset can transform classrooms, communities, and the world. Please welcome to the stage, Ayanna Howard.
So what I'm going to do with this time that I have with you is really challenge you to think about what does engineering education look like for the future, for training our engineers, not for the tomorrow, but for 10, 20, 30 years. And so hopefully at the end of this session, you will rethink how you think about engineering education. So like any good scholar, any good academic, I had to figure out, what do people think about the future? Because as engineers, we have to actually know what people want. And so I did like all of our students, whether it's ChatGPT or Gemini or Claude, you could take your tool of the choice. I asked, what does the future of robotics and AI look like? But my viewpoint is that humans have to always be centered to that loop. And I was actually amazed at some of the things that came up. What I was interested in is that there was images around workforce, around people interacting with AI and robotics together, trying to figure out how to make their situations more efficient, as well as in the home environment where you had robots and people working together around caregiving and cleaning. And I thought, wow, this is amazing. But can our engineers of today create this future? And I would say right now, no. And so I think when I imagine what engineering education looks like, we aren't quite there yet. The engineers we produce today, when they go out, they still have to figure out. They still have to figure out, what does this world look like that the public wants and that we have to enable, because that is our secret sauce. And so I would say, and I'm going to challenge that the EM, the entrepreneurial mindset, is actually a cornerstone of thinking through that. So let's take a step back. It was mentioned my first career was at NASA. When I joined, we were just thinking about how to send rovers to Mars. And I will tell you a little bit of a secret. As researchers, we've been doing robotics for years. In the lab, we had field trials, but they were in deserts. We hadn't actually gone to Mars. And NASA gave us a chance. They created what was called a discovery mission, which is basically, think of it like a capstone project. We're not going to give you a whole lot of money. It's sponsored, and if you make it, okay, and if you don't, we'll just say it's a science project. And so we were all excited, and I will tell you, Pathfinder, Sojourner, was a highly impactful success. So this was the first time we actually had a device land on Mars and actually had dynamic data. It wasn't a whole lot of data, but it was enough, and it was an amazing experience. And so after that became the Mars exploration strategy. We were going to send rovers and landers every 18 months to Mars. And so at the time, I was tasked to lead a team. And one of the things, just like with any competition, there are teams. So I had a team to lead, and there was X number of teams. And so we all had to figure it out using our imagination and creativity to challenge what we knew. And so I decided that I would create a teaming environment that actually brought in the scientists, because trust me, and I asked, if a scientist could go to Mars and return, they would definitely do it, even if it took them 18 months to get there. And so I said, let's bring the scientists on board. Let's try to figure out, how do we have our rovers think like a scientist, think like a human? How do we provide and design the tools to allow that exchange of information? And so right now we call this human-robot interaction. At that time, it was like, you're bringing the scientists into your team, but they're not engineers. But what it allowed me to do was really think about and challenge. And when I say and I think about the EM, it challenges to think differently, which I think is really what was the magic of this moment. And so from there, that became my claim to fame, is that I actually brought in people into the design system. And when I say people, I meant non-engineers. And so that was really the thing, was how to figure out what were the tools that we could create as engineers to bring in different voices, diverse lenses, diverse experiences into the team, and provide a platform so that everyone had a voice. Because that was the only way we could really solve the challenging problems of the future that we yet did not know. And so that is really thinking about engineering education, and where we can go was this element of bringing into the future. I'm going to talk about one other one, just because as I looked at it, the scientists would say, wait, it would be really great if we could actually work with the robots. So it's great, we can exchange information, the robots understand us, but wouldn't it be amazing if we could be in the same environment and work together? And so we did a couple of other studies, and this one is looking at ways to have scientists, in this case aquanauts, which are astronauts that are training underwater, interact with our rovers in the same space. And this was my first time actually looking at this intersection of collaboration, where it's not just this exchange of information using AI or robotics as a tool, but it was thinking about how do you create an environment where your diverse lens includes a robot or an AI agent. And so how do you have humans and AI and robotics in the same space working together? And it's a different challenge. And so when I sit here and I stand here talking to you about the future, and I think about engineering education, I think about the aspiration. And I claim that our aspiration is to think about how do we change, how do we adapt, not just our classrooms, but create new environments, new scaffolds, new training situations where we are inspiring our engineers in the now so that they can create and design and imagine for the future. And I would say, and I would claim that we are not quite there now, but we can get there. And I think through this lens, it's really the challenge is to think about education where we are creating engineers with the assumption that robots and AI will be working with them together. What does that look like? Well, first, we have to think about how do we bring in robots and AI into our own classroom environment. But of course, I'm biased as a roboticist, just so you know. So I mentioned the EM mindset. And I'm just going to take a few examples, and I'm an academic, even though some of my faculty don't realize that. But what this means is that anything that we talk about, anything that we discuss in the education environment, we should actually probe in terms of thinking about the experiment. Does it actually work? And it's nice to have anecdotal, like, yeah, we think it works, but to have real data and metrics to say, here's my cohort A, here's my cohort B, cohort A performed better. We did this around this element of EM and robotics and AI. So I'm going to talk about a few examples, not all of them because I don't have a whole lot of time. So the first one is when you think about one of the elements is you have students. How do you get them to address the different challenges as they navigate this space? How do you model and change some of the project complexity so that you can address them when they are first as freshmen, but as they continue as seniors, they are still using this mindset? And so we looked at one of the examples was in testing. Now, I will tell you, engineers, like every other student, are terrified of tests. Right? They could be the brilliant, they could be the A+++, and put a paper in front of them or you put a screen in front of them, and somehow all the knowledge that they knew when they sat in that front row, for some, it just disappears. And so we said, is there a way that we can change our environment so that when the students come, we can actually test what they know versus testing how well they test? And so we used AI and robotics to do this. So this was an example.
Hello, my name is Arwen. We will be going through a series of 15 math questions to learn the material together. I appreciate you taking the time out of your busy schedule to work with me. Get your pencil and paper ready so we can start. Press begin when you're ready. Keep up the good work.
One more.
You're on a roll.
The last one.
You're doing great. I had trouble with it one too.
So what we found was that when we had the robot there, and just so you know, our cohorts, we did pre-calc and we did calculus. And so we tried to think about the differences of our students coming into the classroom environment. And interesting enough, we examined, well, how did you feel after you taken the test? What was the comparison? Did you feel like you had autonomy? Did you feel a little anxiety? Like, let's think about this. And I will tell you, so this is some of the results for combined calc and pre-calc, and I'm going to put an academic. There is a paper, if you like to, I can give you a link to it. But what I like to show is that I enjoyed taking the test. That one actually surprised. I just thought, but what it says is that when they were in the environment, when there wasn't someone there, when they didn't feel like they were stressed and they had to perform, and you had this positive feedback, even when they got it wrong, like, yeah, that took a little bit of time, but you know what? I have problems with that too. Or, oh, you are awesome, you are a rock star. Having that encouragement live, the robot wasn't giving the answer. They themselves were giving the answer. And what we found is that afterwards, one, in terms of the results, was actually higher with the agent versus not in terms of correct answers. But the way they felt about themselves, the way that they felt about the information, it was like I knew it before the test and I really knew it after the test. Whereas when you ask the cohort that didn't have the agent, it was like, yeah, I think I did okay, but you know, it was really hard. Again, it's about how do you feel? Because our students know the information and testing does not always get that out of them. And so when we think about our engineering and we think about education, we think about the classroom, how do we ourselves create this environment where we can bring in robotics? And we have a number of studies that show that with a robot there, you actually change the environment. You change the empathy, you change the sentiment of taking a test. And so we did another example we thought about, and so here's some things I want to say. We have responses, we always have open source responses, free form responses. I would say about half the students put in like assessing a teacher. Some of it is very useful and some of it is not. And so what we thought about is we had some students that said there was no difference. But what we really wanted to see was, did it across the gamut? And it did. So last one I want to talk about is if you have a robot agent, and so think about this future where in the education environment, you have your personalized agent. So you as an instructor are giving the high level concepts, you're walking through all this knowledge, but then you have an agent that's sitting next to you, or maybe it's in your dorm, or maybe it's in a testing center where the agent is there interacting with you. And what we want to find out as you think about scaffolding, at what point should you give information to the student? When you see a student that's struggling with a concept, at what point should you say, oh, like maybe you should think about it this way? It's what we do all the time, especially in tutoring. How do we think about it with the robotic system? And so here's another example.
3, 2, 1.
I think the sequence is green, yellow, yellow, blue.
So the different examples we thought about is we examined teachers in the classroom to see how did they provide information, how did they provide scaffolding. And so there's 4 different scenarios, and I'll actually show you the graph and explain it. So one is, do you provide a scenario where the student has to ask for assistance? So, and this is solicited. Teacher, I need some assistance with this. I don't understand this concept. Can you help me with this? The other is around unsolicited, where the teacher sort of walks around and is like, oh, you got that wrong, let me help you. So unsolicited, I didn't ask for your help, but sure, come, help me. We also did pre-corrective and post-corrective is this element of before a mistake, I provide some information. So it's basically in real time. And post-corrective is you get through the entire scenario, you're like, yes, you know, step 1 was actually wrong, even though we're at step 10. All right, so let's see what this is. What does this look like? And we added in what happens when the teacher is wrong, because just so you know, AI and robotics is not 100% correct. And even in testing, even when it has 100% knowledge, It will never, ever, ever, ever be 100% correct. Don't let anyone tell you otherwise. And so we wanted to look at what happens if the information was incorrect. And what we found, just a summary, is the best form of communication to our students with robotics and AI is to let them ask for assistance. Let them ask for help. Let them ask for understanding and explaining a concept. And even if the agent isn't 100% correct, what we find is that the student will say, you know what, I'm actually better for it. And so think about this. As educators, what does that mean? We have to basically give our students the ability to know when to ask for assistance. We need to give them the scaffold so that when they are struggling, they themselves can self-reflect and realize, I don't understand, and be okay with that. And I will tell you, based on our studies, when the robotic and AI agent is the one that they're asking, they're okay. They don't feel embarrassed. They don't feel like they don't know. They don't feel shame. They actually are like, well, the robot is here. It is my personal assistant and no one else knows. And so if you think about that, it should reframe how you think about if you have AI and robotics as your partner, as your educational partner, how can you think about the lessons learned about students' interaction in the classroom, outside the classroom, so that you can scaffold learning a little differently? And so I think really the secret sauce, and it's really based on this EM philosophy, is having that curiosity, having that creativity, having those different principles. Curiosity, I'm just gonna kind of hone down, double click on one. One, that exploration of finding a problem, finding the solution, discovering, learning, making mistakes, revising, adapting. It harnesses our intrinsic drive to learn. As engineers, we are pushing and we are focusing, and at the end, the impact that we have when we solve it is so inspiring to our students. And that curiosity is that seed that starts that. And if you think about curiosity, it allows us to be creative. It allows us to take our lived experience and bring it up and bring it into our engineering. And I am a proponent about the lived experience because that allows that curiosity and creativity to come forth. It means that what I create as an engineer is going to be different than someone else from California will create. And so this is really our goal, is to bring out that lived experience and tie it to curiosity and creativity in order to really address the hard problems. And this will be essential because as they go into the workforce of tomorrow, 10 years, 20 years from now, when their co-workers will be a robotic system, definitely, it will be an AI system, 100%, they will have a authority because they have learned it in the classroom. They will not be afraid to have AI as a coworker because they will have trained using it in their day-to-day as a freshman, sophomore, all the way to grad school. And that will ensure that they will be relevant and remain relevant as engineers. And with that, I want to say thank you. And I hope I have caused a seed of inspiration as you rethink what is engineering education for the future and how we can adapt to this. Thank you very much.